Hello everyone, let's talk about velocity. So what is velocity? Well, according to various sites and organizations out there, velocity can be a metric for work done. Velocity can be the total effort of stories that were completed in an iteration. Velocity can be the rate at which a team delivers stories. All of these definitions are fairly similar. Velocity is basically the amount of work a team typically delivers per sprint or iteration. So, how is velocity actually calculated? It's very simple. Let's look at a team that has completed one sprint. There were 3 stories in the sprint. We're using story points as our estimation metric. So we have a 5 story point story, we have a 3, and we have a 2. All we do is add those story points up, and we come up to 10 story points, and that's our velocity. It's as simple as that. We can also estimate velocity over time, over multiple sprints. You'll see the team has now completed 6 sprints, and they have 6 somewhat different velocities each sprint. But you can take an average of that, and you end up with a team that reliably completes roughly 11 story points per sprint. Now, what do we actually use that data for? Primarily, we use it as a projection tool. So let's look at that same team that has completed 6 sprints and has an average velocity of 11 story points. Now let's take a look at their backlog. They have 32 total story points of work in this backlog. Now let's say somebody asks, when do you think this will be finished? When will we be done with it? Well, we can take the team's current velocity, which is 11 story points. We can look at the remaining work, which is sized at 32 story points, and we can simply take the 32, divide it by the 11 story points, and we have a projected completion in roughly 3 sprints. It could be maybe a sprint less, maybe a sprint more, but we have a decent idea that it will take around 3 sprints to complete that remaining work. So now that we know what velocity is and what it's used for, how do we ensure that it remains accurate? Well, there are 3 things that we want to keep consistent in order for velocity to remain usable as a projection tool. We have a need for a consistent iteration length. So if we're running 2-week sprints, we would want to continue doing so. We would want to keep using the same method of estimation. In this case, in these examples, we've been using story points. We would want to continue doing that. And we would finally want to keep a consistent team, preferably in both size and members. So if we increase a team, we would definitely expect their velocity to change in some way. Same if we decrease them. And same if we change the members of a team, because they might estimate differently, and that could change the velocity or render their existing velocity not as usable. So let's talk about a couple of other potential ways to use velocity. The first one is using velocity to measure an individual team's performance. This is a little bit dangerous, and here's one reason why. Let's look at a backlog. Start by looking on the left. We have some work estimated in the blue, and we have a big gray chunk of work that has not been estimated. So a team has a backlog grooming session. They go through that work. They estimate it based on whatever method they use, story points in this case, and we have estimates for that work, and that's great. Now, let's take another look at it, but let's assume that the team is aware that their performance is being measured by their velocity. So what's a way to make their velocity go up? The easiest way is to inflate estimates on stories. So the team could start overestimating stories in their backlog so that their velocity would end up increasing. And that would make it seem like the team is doing really well, but in reality, they're delivering the same working software. Their velocity count is just higher. And we really care about that working software more than the velocity number. We want to use velocity as a projection tool, not a performance metric. Now, another way that velocity could potentially be used is to compare one team with another team. This is also dangerous. And for this one, we have a quote, and it kind of pertains to the last slide as well. Velocity measures output, which is the size of what was delivered. It does not measure outcome, which is the actual value of what was delivered. So let's look at an example here. We have two different teams. We have the same stories. We have one team that estimates the entire bit of work as 32 story points. Now we have another team that estimates this same work as 52 total story points. Maybe because their story point baseline is a little bit higher. Maybe the first thing they ever estimated was an 8. Maybe the first thing the left team measured was at a 2. That means everything for the right team is probably going to be a little bit higher because their baseline is higher. But these backlogs are the same in regard to outcome. We're producing the same value, the same outcome, but it just looks like Team 2 is a higher performing team because they have estimated their work higher than Team 1 has. But in reality, Team 1 and Team 2 are delivering the same, although Team 1 might actually be delivering more because they've estimated lower. It's just very difficult to compare teams with each other in terms of velocity. So to summarize, velocity is a measurement of a team's delivery rate. It is the sum of all work completed in an iteration. It is used for projecting completion dates. It is made more accurate with a consistent team, a consistent estimation metric, and a consistent iteration length. And finally, it's dangerous to use as either a team performance metric or a team comparison metric.